Okay, so we are going to start section 2.3. When we talk about section 2.3, it is specifically talking about a different style of parabola. It's specifically talking about a different style of parabola that we're going to be using. Okay. Now this is going to focus on something. Hey, look at that! You're able to see me up there. Is that what I look like from behind? Yikes, guys! How come no one told me I got so fat? I guess you guys didn't really know me that much, so I mean, when I was in high school, I weighed 185 pounds. I am like an extra half of a person since that point. All right, so the next section is going to deal with a different style or different thing of parabolas that we can actually use real-life applications for. Those real-life applications are going to be dealt very strongly with writing equations, being able to interpret things from an equation, being able to come up with an equation from different things that they give you, and then being able to use those to apply them to other things, okay? So specifically, this is called the focus of a parabola. So this is talking about the focus of a parabola. Now we're going to have to talk about a couple different things before we can actually get into what the focus is and how we can use it and yada, 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 because there's going to be some things that you guys have to be able to recognize when you see a picture, okay? The things that I want you to be able to think about, obviously you know what a parabola is already, right? Parabola is the graph that comes from a quadratic function. But in this term, or in this sense, it's a little bit different because it is the set of all points equidistant from the focus and directrix. Now that's two words that we don't know. So we don't know what a focus is and we don't know what a directrix is. We don't know what either of those two things are yet. Since we don't know what either of those two things are, we kind of need to talk about them and figure out more about them so that way we can use those hopefully in the future, okay? Now that being said, we're not going to dig too far into these types of questions. Like we're not gonna spend 3 or 4 days on these. I just want you to see them because I have seen these on an SAT before, all right? I have for sure seen a focus and a directrix problem on an SAT. And actually, when we get closer to the SAT, I'm going to start giving you guys Khan Academy practice that you guys have to do. Khan Academy loves these. I don't know why, but Khan Academy loves these types of problems. So just kind of keep that in mind, okay? So the focus is it's a point inside the parabola. I know what I want to say, but I can't remember what the book wants me to say. That's on the axis of symmetry. So it is inside the parabola and it is on the axis of symmetry. Okay, what I want you to think about it as is it's actually pretty interesting because if you guys can think of a satellite, if you can think of what a satellite looks like a satellite dish on top of your house, we all know that the satellite dish is shaped like this, right? And then you know that there's a little like receiver right here, right? This is actually the thing that transmits your cable. And the interesting part about that is it is mathematically calculated to be the best point to receive all of those data entries or data inputs. Okay, because the satellite will send the signal to the dish, and then the dish is not actually the thing that picks up the signal, it's this, because those signals come into the dish and then reflect off the parabola directly back into this point. So no matter where they come from, they reflect directly back into this point, okay? That's the interesting part of a focus, okay? It's actually used in real life situations in order for some things like this to happen. It also happens the same exact way with a flashlight. If you've ever seen a flashlight, you've taken the flashlight off, it has a reflective material on the inside, but that reflective material is always like shaped almost like a circle, right? That's specifically because if you look at the inside of a flashlight, there's the bulb, right? There's the bulb that's in here. That bulb will then light up everywhere, right? Like a light bulb sends light in every single direction, right? But a flashlight specifically has a beam that points straight forward. So that being said, all of the light that comes from the top of the flashlight is going to go up, right? It's going to go this way, but eventually it's going to get to the point where it's blocked. And that part is blocked here. That's why they put the reflective material on it, and they make it a parabolic shape, because when it gets blocked here, it gets kicked directly forward. So this is just a quality that the parabola has, that the focus has, that allows you to illuminate certain things, okay? So I don't know if you guys think that's interesting. I actually think that's kind of interesting. I don't know if it actually is or not. This might be my inner nerd coming out, but it is what it is. Right? So that's what the focus is. That's how it's used in real life. That is actually what's used in real life for the focus, okay? The last thing that we're really going to spend a little bit of time talking about is the directrix. This is not as interesting as the focus, but this is a perpendicular line to the axis of symmetry. So this is a perpendicular line to the axis of symmetry. All right. So what this is actually going to look like on a graph, it's going to be pretty straightforward. When you see a graph of a parabola, you're going to see your normal graph, and it doesn't matter where this thing is located. So if I have a parabola that looks like this, I know that my axis of symmetry is going to go straight down the middle. It's going to keep the same qualities that we always used to know. So this is going to be the vertex. And then inside somewhere, and we're actually going to mathematically calculate where the focus is located in these instances, but the focus is located somewhere inside the parabola on the axis of symmetry. So that's what it looks like. I like to use X's for the focus so that I don't get it confused with other points. It doesn't really matter. You'll see me use them in examples in the future. But I want to just kind of note that I use X's when we get to that point. Okay. Now, this distance right here, this distance here, is the same exact distance to what we call the directrix. And the directrix is a perpendicular line to the axis of symmetry. But you should notice that this line and this distance and this distance are the exact same. Those two distances should be the same. Okay. So since they're the same, that creates a few more qualities. Okay. Other qualities that could be created from this, and actually, if you would have learned this before geometry, it could have made your geometry life absolutely miserable. Because one of the qualities that directrix and focuses have is that any distance from here to here is the exact same distance from here to here. I know that my drawing is not perfect. That's because this line is very slanted. But these distances are actually equal to each other. Any distance from the focus to the parabola, and then the parabola to the directrix, those things are congruent to each other. So you can see what kind of issues that would have created in geometry if you decided to learn this early. But that's essentially it, right? So we know what the vertex is, we know what the focus is, we know what the directrix is. Now we just have to learn how to apply them a little bit, okay? And that's essentially what every one of those pictures is going to look like, okay? So we're going to start out, and the only thing we're probably going to have time with today is if we are writing an equation for parabolas that are centered at the origin. But the only thing that's really going to change from this to what we've been doing before is we are going to have now vertical and horizontal parabolas. So before we were dealing with vertical parabolas, which are up or down. Now we're dealing with left and right parabolas as well. So you're going to have to know the difference between those two. Okay. So these are going to be equations that are centered at the vertex, or the origin is the vertex. So that means that they're either going to start from the origin this way, this way, this way, or this way. Okay. So up, down, left, or right. Okay. So what you need to know is if we are dealing with a vertical parabola, it is going to have an axis of symmetry that is vertical. So a vertical parabola, and this should kind of be reviewed. A vertical parabola is going to have an axis of symmetry that is vertical. It is going to be defined by the equation y equals 1 over 4p x squared. Now we don't know what p is yet, right? We don't know what that letter is yet. It is given to you by whatever the focus or directrix are. The focus is the point The focus is the point 0, comma P, and the directrix is the point y equals, or the line y equals negative P. So all of these are going to have the same kind of look. And it's actually just kind of nice if you can figure out what the focus is, you just plug that point in or that number in and you're good to go. So if I'm looking at this on a graph, all of these are going to be centered at the origin, which means that they are going to have a vertex of 0, comma 0. They're going to have a focus point in here that is listed as 0, comma P. They're going to have a directrix down here, which is the line y equals negative P. And then I can create my equation. Because all I have to do is figure out what P is. That's it. All I have to do is figure out what this is right here. And it's literally going to be the point like 0, comma 5 or 0, comma 3 or 0, comma negative 2. Whatever this point is right here, you plug it into that equation and you're done. Okay? So whatever that is, that's it. You're done. So that is a vertical. Now that takes care of both vertical pointing up and vertical pointing down. You always look at whatever the p-value is. Don't say that it has to be positive. It's just whatever the p-value is. So if it's pointing up, it would say like 0, comma 4. You would plug in 4. If it's pointing down and the focus was down here and it was like 0, comma negative 4, you would plug in negative 4. Okay, whatever the p-value is, that's what gets plugged in there. Okay, and then the second one is horizontal, and this is going to be where we stop. So the horizontal is going to have a axis of symmetry that is horizontal, which means that this is going to open left or right. That's what it means. It's going to look this way or this way. That's how these things are going to look. So the axis of symmetry is going to be horizontal. The equation is going to be 1 over 4p y squared. So the equation is x equals 1 over 4p y squared. And then it basically is just going to flip everything out. So the focus is going to be the point p, comma 0. And then the directrix is going to be the point y equals negative p. Sorry, x equals negative p. Okay, and then I'm going to draw that diagram. We're going to call that good for today. I'll throw a couple questions on there for Google Classroom for you guys to look at and kind of attempt to start our conversation tomorrow. Okay, so this is going to look like this, where I'm going to have a vertex at 0, 0, just like we did on the last one. The standard one, the one that's positive, is going to open this way. So this is still going to have 0, 0. The focus is going to be the point p, comma 0. And then the directrix is the line x equals negative. Okay? Any questions you guys can think about with that before I stop recording?